Someone catching the sniffles might not seem the best basis for a film plot, but disease outbreak films are very popular, although often featuring zombie viruses and not necessarily based on anything that could happen in real life. Steven Soderbergh's latest film, Contagion, depicts the series of events that unfold with the outbreak of a new strain of flu. Some of the key stars of the film are public health workers working for the American Center for Disease Control and for the World Health Organization. And the film has quite serious scientific credentials. Ian Lipkin, Professor of Epidemiology at Columbia University, was on hand every step of the way to ensure the film's scenarios were realistic. I'm Sarah Castor-Perry from The Naked Scientists, and I caught up with Professor Lipkin to talk about his role on the film set and also about what kind of public health measures we have in place should an outbreak like this really happen anytime soon.
The most important advance in the past few years has been the international health regulations, to which all of the major countries that are represented in the UN have signed on to this. What the international health regulations mandate is that not only is there a requirement for improving health surveillance in your own country, but also supporting the improvements in the developing world as well. So this means that, assuming that we follow this through to its logical conclusion, that we will have high-quality surveillance all over the world and that people will report in a timely fashion. There are a number of assumptions there, of course, and one is that the resources are available to enable this, and that's not clear right now, and it's become obviously more difficult with the global economic crisis. But nonetheless, there is a firm commitment on the part of the major industrialized nations to make certain that this does come into place.
I suppose it'll be a combination of observing at internal, national-wide levels, but also working between countries at an international level to keep an eye on things and track the movement of such a pandemic.
That's correct. And, of course, one of the things that we would like to do would be to prevent or interdict a pandemic by recognizing potential before something moves from animals into the human population. Fully 3/4 of emerging infectious diseases originate in wildlife and then either move through domestic animals into people or move into people directly. And there are many examples of this: HIV, SARS, influenza virus, West Nile virus. So one of the things we're trying to do is to extend surveillance from the human community into the animal community. So there are a number of efforts that have been led in the UK. Probably the most support has been found through the Wellcome Trust. In the United States, it's USAID. And all these groups are collaborating and trying to support one another in these efforts to identify potential pathogens of humans and animals. Now, sometimes, we focus on gorillas and chimpanzees because we think about HIV and Ebola and Marburg and so on. But over the past 4 or 5 years, people have focused on bats. Bats appear to be tolerant to infection with many of these exotic and highly virulent viruses. So examples would be rabies and SARS and Ebola and Marburg. And the bats don't seem themselves to be affected by most of these pathogens. They seem to be able to coexist with them quite happily until somebody eats one of these bats or there's some sort of transfer of infectious material from a bat to a human.
And so once we know more about the potential for animals like bats and other vectors to carry these infections and pass them on, what can we do with that information?
Well, there are several things. First, of course, is you can monitor wildlife for the presence of these infectious agents. They're not all infected, and they're not always infected. And by tracking the movement of these infectious agents in wildlife, you can understand the risk that might be associated with humans. In addition, you can develop specific measures to address these. So people are trying to develop vaccines against many of these agents. There can be drugs which can be developed. And once you know that a particular agent has the potential to move into humans, it becomes a much larger risk, and you're able to focus investment of resources on trying to address those risks.
It's not just looking at species as well. I understand there's also scenarios where you can model what might happen if a pathogen did move from one of these vectors into humans.
Modeling has really come into its own, really since, I would say, 2001, when we had, immediately after 9/11, when people appreciated worldwide. Although the epicenter was in New York, of course, people appreciated worldwide that we were entering a new era where there was concern for the potential for bioterrorism. So a number of groups around the world began to model what would happen if smallpox were to resurface, for example. If you have a group of people who are susceptible to an infectious agent, how rapidly can it spread? How might it spread via air traffic or travel or even movement of goods? So many models have been developed for looking at foodborne illnesses, waterborne illnesses, airborne illnesses, mosquito-borne illnesses. This is something which is very much at the forefront of research in public health. There are many assumptions with any of these models because you never know how many people are going to be infected and how they might move. And of course, if you're concerned about a bioterrorist event, it need not begin with a single introduction. It can happen in many places independently and simultaneously. But we do the best we can to try to figure out how we can contain such events. One of the things that we've been trying to do as a field in public health is to try to find ways in which we can streamline the process for creating vaccines for new infectious disease threats. When the pandemic H1N1 influenza virus surfaced in the Americas a couple of years ago, it took us fully 6 months to develop a vaccine, to validate it, to ensure that it was safe and efficacious, and then to begin to distribute it. And using modern molecular techniques, we have the capacity to make many vaccines more rapidly than that. And we're trying to find ways in which the regulatory science can be brought up to speed. By regulatory science, I mean the ways in which you ensure that a vaccine or a drug or an antibody or any other sort of biological intervention is safe and effective. We need to find ways in which we can streamline that process and also, of course, make it less expensive.
If we look at something like the recent swine flu outbreak, what do you think we've learned? What lessons have we learned from that outbreak? And do you think we might then use that information to do things differently in the future?
The recent swine flu outbreak emphasized the fact that we need to survey swine. This is not something that we were doing as well as we should have done. One of the problems is that the tests which we employ for monitoring for disease are not as multiplex as we would like. Let me explain what I mean by that, because that's not a familiar term. Most tests that people employ in microbiology, looking for infectious agents, look at one candidate at a time. So they'll test for the presence of flu, or test for the presence of the bacterium associated with strep throat, or test for HIV. Well, we do have technologies now that will allow us to simultaneously screen for hundreds of agents at the same time. So nowadays, when you go in and have a standard history and physical and blood work is done, people measure a whole range of serum chemistries. They measure levels of different salts and sugars and lipids and hormones. We can do the same sort of thing in microbiology, but we haven't. So these types of tests, they're called multiplex because they examine several possibilities at the same time, are beginning to come online. And this will allow us to survey herds. It will allow us to survey people for the presence of any of several infectious agents. The other thing that's changed a great deal has been advances in sequencing technologies. So the ability to determine the genomic composition of a sample has allowed us now to do what used to take weeks to characterize a new agent. So when SARS emerged in 2003, there were huge efforts all over the world to try to identify the complete sequence of the genome of this virus. And the first group that reported a full-length genome was in British Columbia, and it took them a week, and there were huge numbers of people and resources involved in doing so. With some of the new sequencing machines that are available, we can do that same sort of work in a fraction of the time, but a fraction of the cost with many fewer people. So we do have the ability now to get that kind of information quickly. The other thing that we're trying to do, and when I say I mean really the whole field, is to find ways in which we can understand why some people who get exposed to infectious agents have severe disease and some people have only mild disease. Not everyone exposed to West Nile virus, for example, develops West Nile virus encephalitis. You can make some sort of projections based on age and their general health status, but there are genetic factors that are important as well, and exposure to other infectious agents during the swine flu pandemic, we did some work in Argentina looking at people who had severe disease. And one of the things that we learned was that if you had not only the influenza virus infection, but also infection with a very common bacterium known as Streptococcus, you had a 125-fold increased risk of severe disease. And that suggests that you not only need to protect against viral infections for flu, but also against bacterial infections. And the streptococcal vaccine is very inexpensive, and it's very safe. And certainly for elderly people and for children and those who might be at increased risk, I think it's a very good idea to not only take the influenza vaccine, but also to have this streptococcal vaccine, which protects against the most important forms of that bacterium.
So it seems like there's an awful lot of sides to addressing, obviously, something that is an extremely complex problem. There's modelling, looking at potential vectors, there's the sequencing of new viruses that come up, and also looking at potential side-along infections like the strep bacteria. When you were approached to do the film, were you really keen to make sure that it addressed the different sides of a potential pandemic?
Well, to be honest, the most important thing was to figure out whether or not these guys were sincere about making a great film. I wanted to make sure that it would be an entertaining film, that people would want to go and see it. The screenwriter who approached me initially, Scott C. Burns, was a very serious guy, and he said, look, I want to make something that's real. I want to make something that's important. Obviously, we need to fill theaters, but when we're done with this, we want to feel as though we've made a contribution. So we ran through a series of different scenarios. Which viruses were of interest, where might a virus originate, how would it spread, and I got sucked in, quite frankly, because it was a lot of fun thinking about the ways in which we might be able to convey this message. I think they did a very good job. I mean, there were a couple of points where I think things might have been done a little bit differently, but by and large, the film is accurate and it's timely, and it has had an impact in many ways. Not least in that it's drawn attention to the people who do this kind of work day in and day out, many who don't receive much in the way of accolades for the work that they do, some of whom die in the course of doing this work. But, we try to emphasize the fact that it doesn't make any difference how much money you have or how powerful you are. Everyone is equally vulnerable, and that it's important that we invest in this. And I think this is key, particularly as we head now into this situation where people are reluctant to spend money in public works. Everyone is at risk. You can't hide from infectious diseases, and it's important that everyone be protected. I'm very proud of the film, and it was a great deal of fun to make, I have to say. I didn't anticipate it was going to be as much fun as it was.
What did you enjoy most about working on it?
Every night when we would finish the day's work, we'd repair to the bar, and Soderbergh would pull out the film on a laptop, and he would edit it at the bar, and we'd sit there and look at scenes and begin to understand how we put the film together. Much of it was shot out of sequence because it's difficult to get these actors to commit, for several weeks at a time. So, of course, somebody has to keep all of this in his head, how it's all going to come together at the end. And it's an extraordinary team effort, and they're absolutely brilliant. You would have a chance to see how he would use subliminal cues to direct the viewer towards certain things. So he used a minimum number of lenses so that, the focus really would be on the action and on the story. There was a slight tint to the film that would represent different cities, which would help you maintain continuity. Occasionally, we would have to rewrite scenes on the fly, which was a lot of fun. It was very exciting to do that and see how the process developed. And I had a feeling I was witnessing, one of the geniuses of this particular medium and how he puts things together in his head. So it was an extraordinary experience. It was like being in a master class and watching how things came together. And the actors were, many of them are brilliant, absolutely brilliant. And you could see how they could approach films, and they could flip in and out of characters. So it was an extraordinary experience. And the use of special effects and how things came together, because I had an opportunity to help with some of these special effects in designing the virus and creating three-dimensional models, and it's really quite remarkable.
And what would you say the kind of take-home message of the film was? You said it was very accurate. Is it kind of Not necessarily trying to scare people, but trying to say, this is a possibility, this could happen?
I think there are several take-home messages. I don't know that I can really prioritize them, but I think you've nailed the first one, and that is to say, there is risk. The risk can be contained. It's something about which we need to be aware. Secondly, that this concept of One Health that's been promoted recently, the notion that there is no difference between human health and animal health, we're intertwined, and we need to survey wildlife for infectious diseases. It would be a second point. A third is that the people who are engaged in public health are heroes, and they need to be recognized as such, and they need to be supported. When we do our jobs well, nobody really hears about it. That's one of the challenges, I think, with public health. And we try to emphasize and create a living memorial to people like Carlo Urbani, who gave his life, in addressing SARS. The fact that no one is beyond the reach of infectious diseases, therefore we need to protect everyone everywhere. And that there's a potential for breakdown of the social fabric. It's really a very thin veneer of civilization if you think about it. And this is what you see in the streets where there's looting. We also talked about people who are exploitive, and we saw that during SARS, and we saw that during various influenza pandemics, where people who are unscrupulous come in and try to use these events for their own means, and getting in the way of vaccines. One of the other things we were trying to tackle here was people who are against vaccines and who put forward, who fearmonger on vaccines. But, vaccines are really the only way we have that's sufficiently inexpensive that we can offer this to the world's population to control infectious diseases. So when Jude Law says, vaccines aren't safe and so forth, this is something that we contend with in public health all the time. There, of course, are situations where vaccines, there are some people who have idiosyncratic adverse reactions to vaccines, but in terms of protecting population health, there's really nothing else like it.
That was Professor Ian Lipkin from Columbia University talking about how Contagion celebrates the unsung heroes of our public health systems. For more science interviews, join us online at thenakedscientist.com.